Hello students. Now today
So in the last
we will
video,
discuss about ferrous
we
materials.
learnt about steel as a ferrous materials.
And today we will continue the same session and we will discuss the another form of ferrous material as a cast iron. So we know that the cast iron basically a ferrous material which contains more than 2% of carbon in its chemical composition. So let us go back to the classifications again. The metallic materials under ferrous and non-ferrous category. In ferrous, steel and cast iron. These two categories are based on percentage of carbon. Steel up to 2% of carbon, cast iron more than 2% of carbon, and this category, the entire category of steel, which we have already learnt in the last video. So today we will study cast iron, and the different types of cast iron depends on the nature of the carbon. It's further characterized as gray iron, ductile iron, white iron, and malleable iron. So let us understand first cast iron in broad perspective. Same like steel, cast iron is obtained from a pig iron, and the pig iron basically is obtained from the iron ore, and this pig iron is processed through a different furnace and processing routes, and ultimately the material is derived in such a way that it contains 2 to 4% of carbon and some proportions which are very minute in numbers, so small proportions of other elements such as manganese, silicon, and some impurities in form of sulfur. So same like a steel, cast iron contains main element as iron because it is a ferrous material, correct? Then carbon range from 2 to 4%, then very small fraction of silicon up to 3%, manganese very small fractions maximum 1%, and other form of elements impurities such as phosphorus and sulfur up to 0.2 to 3%. And these impurities have no influence on the properties and the structure of cast iron. So the property and the structure is governed by this percentage of carbon and how this carbon is reacted with the major element, that is Fe component or iron. Now properties of cast iron, right? What kind of properties an iron possess? Very good tensile strength, right? 350 megapascal, quite good mechanical properties. The strength property, the most important property, or you can say the USB of cast iron, is a very good compression strength. Now remember, the compression strength is required when you are looking to absorb some shocks under the applications, right? So when you are looking good damping properties, damping means good shock absorber, then cast iron is used. And that's why if you see most of the machine tool, bed of the machine tool or structure of the machine tool, like lathe, milling machine, drilling machine, all these machines, bed or structure, they are made of the cast iron, because when the machining is going on, there are huge amount of cutting forces are developed, and it becomes very important to absorb those cutting forces, so it should not influence the actual machining process which is going on. So compression strength, cast iron is the best material to be used. Very good immersion capacity, good wear resistance, machinability, So one can machine cast iron very easily, and low impact resistance and ductility. So these are the inferior properties we can say that the cast iron possesses: low impact and ductility. Types of cast iron. So as we saw in the previous slides, that gray cast iron, white cast iron, malleable cast iron and ductile cast iron, these are the main four cast irons available as far as the commercial material is concerned. So let us go first, that is a gray cast iron. Now just observe this microstructure for a few seconds. So if you observe this microstructure, then you can see these are the number of flags, the lines you can see. This is one line, two line, three, or you can see the flags having some branches. So basically these flags are nothing but the graphite, right? Here it is mentioned. So if you see the microstructure of gray cast iron, then you can see clearly the flags in form of thick lines, and that is nothing but the graphite flags. And that is the reason that this cast iron is known as a gray cast iron. These flags are gray in picture, right? So this is known as a gray cast iron. Another reason that why it is called a gray cast iron. So when you break any gray cast iron, any cast iron, when you break it in two pieces, then if you see the fractured surface, then the fractured surface will appear in form of gray color, and that gray color is nothing but representing these graphite flags. So that is the reason that this cast iron is known as a gray cast iron. Now look, going to the more detail, that it contains carbon in a range of 1.7 to 4.5%. That is quite high. And most of the carbon is in free state. What is meaning of free state? That means this percentage of carbon available in gray cast iron are not chemically reacted with any of the ferrous component. So it does not form any ferrous carbide or iron carbide. All the carbons, most of the carbons are in a free state in form of these gray flags. Right? And because the carbon is in free form, so basically it causes a brittle failure or brittle fracture under the loading condition. So one of the reasons that this gray cast iron is more brittle in nature, that is only because of the presence of these gray flags or graphite flags. So these graphite flags basically provides more brittleness, right? So when the fracture happens, when the crack is in contact with the graphite flags, it completely gives you a brittle failure. A similar point I have mentioned that the fractured surface look like a gray, that's why it is a gray cast iron. And the applications of gray cast iron, you can see a number of applications such as hydraulic components, automotive suspension components, power shafts, most of the casing of pump, housing and casing of the pumps, linkages, and so on. You see all the applications. Also in automotive industries, you can see some agriculture vehicles like a tractor parts, valves, suspensions components. So here you can see the suspension components, because having a good compression strength, so they can absorb the shocks quite easily. So this is a gray cast iron. The second type of cast iron is white cast iron. So white cast iron contains 2 to 3.5% of carbon. So as the name suggests, if you see the microstructure, you will see the surface, most of the surface in form of white. Or if you break this cast iron into the two pieces, the fractured surface will appear as a white color. That's why this cast iron is termed as a white cast iron. Now, if you say that how it is produced, so this white cast iron is made by a rapid cooling of the pig iron which is already melted inside the furnace. So by having a rapid cooling, you can obtain this white cast iron, and it is different in nature if we compare white cast iron with the previous cast iron, that is a gray cast iron. So here in this white cast iron, most of the carbon is chemically combined state, right? So here the carbon is not in free state, unlike gray cast iron, but it is chemically reacted in form of cementite phase. So this cementite, which is a phase of iron and the carbon, and they combine together and they form this Fe3C, and this phase is known as a cementite. And this completely Fe3C, this combined phase, is very hard in nature. So that means the white cast iron is more harder than the gray cast iron because of this Fe3C component, right? So here you can see that it is mentioned that since this white cast iron is very hard in nature, it is difficult to machine. So if I have a round bar of white cast iron, if I want to machine in my workshop, then it will be challenging for me. But if I have a gray cast iron, then easily I can do the machining of required size and shape. So most of the cases it uses a multi-point cutting system, that is a grinding. So it is cut by the grinding wheel, right? And in order to avoid the machining, what is the best manufacturing process for white cast iron? So for that it is used casting, right? So the casting as a manufacturing route is suitable for processing this white cast iron. So if I want to manufacture some component of white cast iron, then I will select a casting as a manufacturing process instead of the other process like machining. Why? It's very hard. Also joining, welding also will be hard because it is very hard in nature. Why? Because of Fe3C, cementite or iron carbide component. So this is about the white cast iron. So you can also try to compare gray cast iron versus white cast iron. So at the end of this video, you try to compare white cast iron and gray cast iron, and you will come to see that what is the possible applications and how it can be manufactured via particular manufacturing process. The third type of cast iron is malleable cast iron. So basically malleable cast iron is obtained from the white cast iron. So if I want to have a malleable cast iron, then I must need a white cast iron as a raw material. Again I am repeating, if I want to derive a malleable cast iron, then I need a white cast iron as a raw material. So when I do some heat treatment on my white cast iron, and I can convert that white cast iron into the malleable iron. So when white cast iron is heated at a higher temperature for more than 100 hours, it gets converted to the malleable iron. Now there is a purpose behind this heat treatment of the white cast iron. Why? Because we know that white cast iron, the carbons are not in free state, right? The carbons are chemically reacted with the iron and it forms cementite. Basically it is a Fe3C. So what happens when you do heat treatment, when you heat white cast iron at higher temperature for prolonged time of period, then what happens? The combined form of carbon is converted to the free carbon, right? So the combined state as a Fe3C, the cementite is what? This is a Fe3C. So it gets converted to the free carbon at high temperature and with having the enough amount of time, because you give enough amount of time to make sure that all the combined state of Fe3C gets converted to the free carbon. So, and whatever the iron you get, that is a malleable cast iron. You can see here number of free carbons in the microstructure, right? And you can see that more number of free carbons when you are heating the white cast iron, then what happens? The combined state of carbon becomes free and more number of free carbons agglomerate or make a cluster and they form this kind of appearance. You can see here in this microstructure. So the main purpose is that the white cast iron is non-machinable because of combined state of hard phase of cementite. Now if you can get malleable cast iron by doing heat treatment, you can improve the machinability of the cast iron. So this cast iron becomes a little bit softer compared to the previous one, that is a white cast iron, and also it's have a very good characteristic of machinability. So the machinability becomes little bit easy, right? So this is a malleable cast iron. So remember, the malleable cast iron is obtained from the white cast iron through a heat treatment process. Heat treatment is what? Heating at higher temperature and holding that temperature for very long time of period, more than 100 hours. So this is a third type of cast iron, that is a malleable cast iron, right? So this malleable cast iron, another important thing I would like to draw an attention, students, that it possesses a good malleability. Now we have studied already the malleability is one of the important mechanical properties, right? Before mid semester we studied malleability. A malleability is what? How you can form the material very easily. A malleability means like a hammering. By hammering, how you can easily shape the product or the material in different shapes and size, just like a hammering, just like a pressing. Okay, how I can press the material of different thickness. So a malleable cast iron means it's very soft and machinable, so we can form this cast iron with quite ease. So that possesses a malleability, so you can form the metal in different size and shapes. So here the metal forming comes into the picture. Okay, so metal forming, if you are looking, then malleable cast iron is the better choice of ferrous material among all cast irons. The fourth and the last one of cast iron is a ductile cast iron, or sometime it is known as a nodular cast iron. So as you can see on this microstructure, you can see this nodule of carbon. You can see these are grains of ferrous material, right? Fe component, and you can see one big size round particles in form of carbon. So this is a free carbon in form of nodule. That's why it is known as a nodular cast iron, right? So that's why this is known as a nodular cast iron or ductile cast iron. So carbon is in free state in a nodule shape, you can see here, right? And this nodular cast iron or ductile cast iron is produced almost similar to the gray cast iron. The only difference is that sometimes some magnesium alloys are added when we are manufacturing or when we are producing this nodular cast iron through melting, right, in a furnace. So that is the only difference. More or less is similar to the gray cast iron. Carbon is free, but the shape of the carbon is in a nodule shape. While in case of gray cast iron, the carbon was also free in state, but the shape was like a graphite flakes that we have already seen. So in gray cast iron, the carbon is in graphite flakes, means thick lines. Here the carbon is in a round shape or nodule shape. Now from property point of view, this cast iron has similar properties like a malleable cast iron, right? So basically it is a very tough, means that will offer you good damping characteristic. Machinable, that means that will allow to machine with quite ease, and it possesses many of the characteristics of the steel, right, in terms of the tensile strength. So basically it is used for making very tough casting for automobiles, because in automobiles we know that if you see the housing of a gearbox, right, a lot of forces develops, thermal forces, mechanical forces, and it has to be absorbed. So you can say that the tough casting for automobiles, farm machineries, and many more components of the machineries. So this is all about the white cast iron. So now we have studied the cast iron as well as the steel. So we studied the ferrous materials. So it is basically the introduction of the ferrous materials. Now to develop more understanding, we must be able to differentiate steel and cast iron. So let us try to prepare a detailed comparison of steel and cast iron. So that is the exercise for you. You just try to make a one-page comparison, left hand side steel and right hand side cast iron, and try to differentiate on these aspects. So the aspects I have written, that is the first aspect, we should differentiate steel and cast iron. The first aspect is the structure. So the structure of steel and structure of cast iron, how it is differ, right? So here you can talk more terms about the available carbon, in which form, and how it is reacted with the ferrous, right? The second is a property, which is very important for comparison of any material, not like steel and cast iron, but for any material, the property is a main component for comparison. So property for steel and property of cast iron. So property, what about the tensile strength? What about the ductility or toughness? What about wear? What about the hardness? What about impact strength? So all these properties you can compare steel versus cast iron. And based on this comparison, one can decide which material to be used for particular application. So next is application. So what is the application of steel and what is the application of cast iron? Low end application, high end applications, or niche applications of steel and cast iron, right? So you can list at least 5 applications, very specific, specific applications of steel and cast iron, and make sure that you give the applications in such a way that only this materials is the best candidate for a particular application, right? Then heat treatment. As we know that the heat treatment is a crucial, is a property decider for any fabricated or manufactured component. So heat treatment. So whether all steels are heat treatable or whether all cast irons are heat treatable, if they are heat treatable, then what kind of enhancement in the properties we can get, right? So also you should compare based on the heat treatment. Which heat treatment is suitable? Tempering, annealing, right? Normalizing. What kind of heat treatment is applicable in case of steel and cast iron? So that is another aspect for comparison. Then manufacturing processes. How we can process steel and cast iron. So which manufacturing process is the best suitable for steel and cast iron? We know manufacturing processes, right? Whether we will go for metal forming, metal casting, metal cutting, metal finishing, metal joining. So which kind of manufacturing process is convenient for steel and cast iron? So that also one of the aspect of comparison, right? And last but not the least is an economic factor or aspect based on which we can compare steel and cast iron. Economic means what is the cost of the raw material, a steel, right? In steel, if we see in detail, a plain carbon steel and alloy steel, right? So there will be a different prices. So steel, and in steel also you will have different prices as far as raw material is concerned, same like in cast iron. So this is for the raw material. Now economic point of view is also consider of manufacturing process. Let us say that out of these two material, one material is a less expensive. If I buy a raw material, that will be less expensive. But then after, if I will go for a manufacturing process to make the final product, then my manufacturing process may be a little bit complex and tedious, and ultimately whatever the product I am manufacturing, the total cost will be more like, it will be more than whatever I have thought for the base material. So economic point of view, the cost of the material as well as the manufacturing process, and if we combine these two costs, that will come to the total cost of the final product. So this is the aspect that should come for comparison. So here is the end of the cast iron session. So let us summarize the two sessions, right, of ferrous materials, steel and the cast iron. In a steel we learn different steels, especially we learn the plain carbon steel under the category of low alloy steel. Then we saw the cast iron. So we know the properties, chemical composition, the applications. So now try to summarize steel and cast iron in a such a way that you should have a clear fundamentals of ferrous materials. Now next category will be the non-ferrous materials, right? So ferrous materials, it contains Fe component, right? Non-ferrous, it possesses no Fe component or very limited number of ferrous in the chemical compositions. So non-ferrous materials. So non-ferrous materials, we know that aluminium, copper, magnesium, titanium, right? So all these materials come under the category of non-ferrous material. But the non-ferrous material, the metallurgy is completely different. Non-ferrous materials, you will not find carbon either in form of free state or combined state. So carbon is completely absent. So microstructure and the metallurgy is completely different from the ferrous material. So next sessions we will discuss about the non-ferrous material, mainly aluminum, copper and magnesium, right? And our main focus would be for the aluminum, because we know that aluminum is a very popular material as far as the structure application is concerned. Why? Because aluminum gives a very good advantage of strength to weight ratio. So if you say that the vehicles, automotive vehicles, right, they have used extensive amount of aluminum, especially electric vehicles, right? We know that the entire world is moving towards electric vehicles. So electric vehicles weight reduction even is much more crucial. So aluminum plays a vital role as far as the battery housing is concerned or any structural member is concerned. So you can reduce the weight and you can have the better performance, right? So thank you very much for listening to this video, and make sure you will be reading the respective books. Do not restrict yourself with these contents. Go to the depth of the each contents and read from the book whatever you are following. I think we are using Callister as a textbook, so please read that book and make sure these fundamentals are crystal clear. Thank you.